Continuous Time Fourier Series, and this is part 8. Last class we have seen the symmetric condition. Knowledge of symmetry can reduce the complexity of solving Fourier series coefficient. So first of all, tell me, am I audible properly? Audio and video both are clear to you people? Continuous Time Fourier Series. So in last class we have seen the symmetric condition. Say for example, if signal is even signal or signal possesses the even symmetry, or it is also known as Meron symmetry, then what is the effect on the coefficient? So we can say DC may or may not be 0 if it is an even signal. AN will be always non-zero, so cos term will come always, but BN will be always 0, no sin term will come into picture, okay, whenever signal is even. In the similar way, the signal is odd. Suppose the signal is odd, guys, then if the signal is odd, then DC will be always 0, like this. This is the odd signal, this is also odd signal, so DC will be 0, no cos term will come, only sin term if signal is an odd signal. Then next is hidden symmetry. Now hidden symmetry is to identify whether the hidden odd symmetry is there, hidden even symmetry, hidden half wave symmetry, or half even symmetry, half wave odd symmetry. Okay, this is the use of hidden symmetry. So you have to use hidden symmetry only when DC is non-zero. Whenever DC is non-zero, use hidden symmetry concept. So what you have to do, simply subtract whatever DC present from the signal, from signal itself. Okay, so simply draw a straight line from the center, so it will be your new x-axis, and with respect to that x-axis you have to check the symmetric condition, whether it is an even signal, odd signal, halfway odd, halfway even signal, correct? And the next one is half wave symmetry. Half wave symmetry, so half wave odd symmetry or half even symmetry. So what is the condition for a signal to be having an half wave or half wave odd symmetry? If x of t is equal to minus x of t plus or minus t by 2, then half wave odd symmetry is there, and only odd harmonics will come into its Fourier series representation, correct? Like omega 0, then directly 3 omega 0, 5 omega 0, 7 omega 0, and so on. And this is the example. So how to check half wave odd symmetry is present or not? So first take only half wave and shift that half wave towards right side or left side by half fundamental time period. Then next, folding with respect to x-axis, and if it overlaps the original signal, then we can say half wave odd symmetry is there and only odd harmonics will come, correct? Fine. Now next, in the similar way, half wave even symmetry. So this is the condition for half wave even symmetry. X of t is equal to plus x of t plus or minus t by 2. Fine. Now quarter wave symmetry. What are the different conditions for the signal to be having a quarter wave symmetry? So first of all, it should be an even signal or odd signal, plus as well as it should have half wave, any half wave symmetry, half wave odd symmetry or half wave even symmetry, correct? Now let us solve some question, guys. The summary, guys. Already I told you summary. Now let us start with the very first question. The question is x of t contains which components? You have to tell me only odd harmonics or only even harmonics, only sine, only cos, this will come or not. So first step is check the normal symmetry, whether it is an even signal or odd signal. So you can see here, area of first quadrant is equal to area of third quadrant. Here this is an odd signal, correct? First step is an odd signal. Odd signal, correct? Is an odd signal. So odd signal means what? DC will be always 0, no DC term will be always 0. no cos term, an will be 0, and only sin term will come, correct? Only sin, an will not be equal to, fine. Directly you can say a0 will be 0, an will be 0, an will not be 0, only sin term, okay. Now you have to check whether the half wave symmetry is present or not. So for that, take any half cycle, guys, any half wave, positive half wave or negative half wave, any half wave to take. So you can see here, this is the fundamental time period from -3 to +3, the total fundamental time period. What is the fundamental time period? 6. So take any half wave, guys. You can see here, this is the positive half cycle and this is the negative half cycle. You can take any. So let us consider, I am taking this one. This is the half wave. Let us consider this half wave. So this is x of t. Let me write this is x of t. Let us consider x of t. Okay. Now shift this half wave either right side or left side by half fundamental time period. Let us shift this half wave by left side or right side by half fundamental time period. So total fundamental time period 6, half fundamental time will be 3, guys. So shift this half wave by left side or right side by half fundamental time period. Okay, I always use left side for simplicity. So if you shift this left side by 3 seconds, half fundamental time is 3 seconds. So this 0, this will come at -3, this will come at 3. So it will be like this. This is the step shifted by half fundamental time period. Can we say this x of t plus half fundamental time period, step shift. You can do right shift also, correct? And then it is not overlapping with original signal, so there is no half even symmetry. It is not equal to x of t. See, this is not equal to x of t, correct? It is not equal to x of t. It is not equal to x of t, guys. Not equal to x of t. So there is no half wave even symmetry. Next, folding with respect to x axis, amplitude reversal. So folding with respect to x axis, this amplitude is +2, now it will become -2, guys. This is what folding with respect to x axis. Here this is minus x of t plus t by 2. And yes, it is overlapping with the original signal, equal to x of t. So we can see here, there is half wave odd symmetry. Half wave odd symmetry means only odd harmonics. What will be the final answer? The Fourier series representation. See, no cos term, no DC, only sine. So the final answer is only odd harmonics of sine, only odd harmonics. Why only odd harmonics? Due to half wave odd symmetry. So only odd harmonics of this. It's a Fourier series representation. Trigonometric Fourier series representation contains only odd harmonics of sine. Only odd harmonics of sine, guys. Clear? Tell me in the comment box. Is this clear to each and everyone? Only odd harmonics of sine, guys. So in this way we can solve the correct answer, and this approach we can use in option elimination method also. Suppose in any option if DC is given, then that option will not come into answer. Suppose cos term is there, then it will be eliminated, correct? So next question, let us take next question. Again same question, x of t contains which components? So first of all identify the symmetry, standard symmetry. Which symmetry is there? Even signal or odd signal. So you can see here, this is even. You do the folding with respect to y axis, then you will get the original signal x of t equal to x of minus t. So this is an even signal. Even signal, then what is the confirm part? If it is an even signal, then directly we can say there will be no sine term in it's a Fourier series representation. No sine term. Okay, confirm. So we can say n is equal to 0, guys. n is equal to 0. Correct? n is equal to 0, guys. Fine? n is equal to 0. Now we have to check DC will be 0 or not 0. Bn will be 0, and only cos term, so an will not be equal to 0. Now we have to check DC may or may not be 0. If it is an even signal, then DC may or may not be 0. So we have to check whether DC will be 0 or not. What is the fundamental time period? We can say minus 3 pi minus pi guys. This duration is 2 pi, this duration also 2 pi. So this is the fundamental time period. What will be the fundamental time period? So minus 3 pi to pi. So the fundamental time period is pi. Okay. Now this is the negative half cycle, we can say. This is the positive half cycle. Here amplitude is minus 3, here amplitude is plus 3. Here duration 2 pi, here also duration 2 pi. So area of positive half cycle is equal to area of negative half cycle. So of course DC will be 0 because total area over the fundamental time period is 0. That's why DC also 0. Correct? So here we can say DC is 0. No DC term. Correct? DC is 0. Whenever DC is 0, need not require to check the hidden symmetry. So only cos term will come. Now in cos, we have to check only odd harmonics, only even harmonics, all harmonics come. Correct? Got it? Fine. Now we have to check only odd harmonics or even harmonics. So for that you have to take any half wave, guys. So let us consider this half wave, this one, this triangle in minus pi and pi. Let us consider this x of t. Now shift this x of t left side by half fundamental time period. Total fundamental time period is 4 pi. Half fundamental time period is 2 pi. So this is 0. Shift left side by 2 pi. So it will at minus 2 pi. Minus pi will come at minus 3 pi. Pi will come at minus pi. Shift left side by half fundamental time period, that is 2 pi. It will be like this. So this is what x of t plus half fundamental time. It is not overlapping with the original signal. So that's why here there is no half even symmetry. Then folding with respect to x axis amplitude reversal. So here plus 3 amplitude, it become minus 3 amplitude. It will be like this. What? Folding with respect to. Folding with respect to what? X axis minus x of t plus capital T by 2, which is equal to x of t, guys, which is equal to x of t. So that is half wave odd symmetry. So half wave odd symmetry means what? Only odd harmonics. Half wave odd symmetry is present. So now what will be the final answer? DC 0, there is no cos term, but there is no sin term, guys. Okay, there is no sin term. The previous question, yes, and here Bn is 0. No sin term. No sin term, guys, only cos term. DC 0, no sin term, only cos term. And in cos term, only odd harmonics will come into picture. So what is the final answer? It's a Fourier series representation. Only odd harmonics. Only odd harmonics of cosine. Only odd harmonics of cosine, guys. Correct? Only odd harmonics of cosine will come. Is this clear? Tell me in the comment box. Sinchan Reddy, if you are present, then tell me, is this clear to you? Okay, let us take one more question. X of t contains which component? So first of all, tell me odd symmetry, even symmetry, or nano. So of course there is neither even nor odd signal here. Nano directly if you say, then it is neither even nor odd signal. DC is 0 non-zero. The next step is DC is 0 non-zero, guys. So of course there is no negative half cycle or there is no negative amplitude, only positive amplitude over a fundamental time period. This is the fundamental time period from here to here. Okay, so no negative amplitude, that's why area will not be 0, guys. So that's why DC will not be 0. So here DC C not equal to 0, correct? So DC is present. So I told you guys, whenever DC is present, then call SID, Symmetry Investigation Department, we can say. So you have to check the hidden symmetry. Hidden symmetry. So simply what you have to do, guys, we draw new x-axis from the center. From the center, draw the new x-axis. Correct? Okay. So this will be a new x-axis. Just forget this one. Now observe this signal. So it is even or odd. You can see here. It is -1. Now one is of course -2 and -1. Between 0 and 2 it is 1, guys. You can say now this again same fundamental time period from -1 to 1. Now tell me, it is an hidden odd symmetry, hidden even symmetry, or again it is nano? So we can see here it is an hidden odd symmetry, correct? You can see here this is fourth quadrant, this is second quadrant, first folding with respect to y-axis, then folding with respect to x-axis. So here hidden odd symmetry, correct? Hidden odd symmetry. So whenever hidden odd symmetry means what? See, DC already present, guys. Now hidden odd symmetry, so that's why we can say there will be no cost term, an will be 0 and Vn is not equal to 0. See, DC already there, guys, but hidden odd symmetry is there, that's why hidden odd symmetry is there, that's why no cost term, only sign term. Now next we have to check half wave odd symmetry. See, in each and every question you have to check half wave odd symmetry, guys, or half wave even symmetry, correct, in each and every question, because half wave symmetry gives whether odd harmonics or even harmonics will come into picture, will come into its Fourier series representation. Okay, so take any half wave, guys. This is the negative half cycle, we can say this positive half cycle. So I am considering this one. Okay, let us consider this half cycle. Okay, this half cycle. Okay, it is x of t. Now shift this half wave by the half fundamental time period left side by the half fundamental time. What is the total fundamental time period? Half fundamental time period is 1 second. This is origin. Okay, shift this left side by 1 second. So this 0 will come at -1, 1 will come at 0, guys. Like this. Left side. Like left side by this. Now next is what? Folding with respect to. Shift this half wave by left side by half fundamental time period. Now folding with respect to x-axis. Folding with respect to x-axis like this. Correct? Folding with respect to x-axis like this, guys. Fine. Okay. So you can see it is not overlapping with this minus x of t plus by 2 is not overlapping with x of t guys. It is not overlapping with x of t, correct? So there is no halfway even symmetry, there is no halfway odd symmetry guys. You can see here, you are folding with respect to x axis amplitude reversal. So there is no half wave odd symmetry, there is no half even symmetry. So all harmonics will come into picture. What will be the final answer? So in the it's a Fourier series representative, DC already there. So DC plus DC plus all harmonics of sine, all harmonics of, correct, because there is no half wave symmetry, no half wave odd symmetry. Fine. Okay, very good. Now let us take one more question. Try this one. Which harmonics will come? So first of all, fundamental time period is from -2 to +2, or we can say from -3 to +1 also, or fundamental time period is equal to 4. Fine. So you can say the half cycle. Fine. Now first of all, check here which kind of symmetry is there. Half wave odd, odd symmetry, even symmetry, or nano. So you can see here, this is the even signal. Symmetry is present. Even symmetry. Even symmetry. What is the confirmed part? Even, no cos term, no sin term. N will be 0. Cos term will be there. And DC guys, you can see here DC will be 0 or non. DC is 0 or non-zero. So there is no negative half cycle. Only positive amplitude. So if there is only positive amplitude, so non-zero area will be non-zero. So DC will be non-zero. So here DC is there guys. There DC is non-zero. Okay. So only DC and cos term will come. Now in cos term you have to check only odd harmonics, only even harmonics, or both. So for that, half wave symmetry guys. So see, DC is non-zero, so that's why I call SID. Hidden symmetry. Hidden symmetry gives you half wave odd symmetry is there, half even symmetry is there or not, correct? So simply draw a center, line from the center guys. Line from center, correct? It will be your new x-axis. Your new x-axis, correct? X-axis. Subtract DC. Simply draw the line. Okay. So this will be your positive half cycle. This will be a negative half cycle, correct? This will be your negative half cycle. This will be your positive half cycle. Are you getting this part, guys? This is the negative half cycle, positive half cycle, correct? See, now here you can see this is your negative half cycle, this is your positive half cycle, or you can say, see, your positive half cycle, your negative half cycle. Getting? Here you can see your positive half cycle, this is your negative half cycle. Now you can take any half cycle. So let us consider this is the half cycle. X of t, correct? X of t. Now shift this half cycle towards left side by the half fundamental time period. So total fundamental time period is 4 seconds, half fundamental time period is 2 seconds. So shift this left side by the half fundamental time period. So this -1 will come -3, 1 will come at -1 because half fundamental time period is 2 seconds. Subtract 2 from this, it will be -3. Subtract 2 -1, so it will be like this. Correct? So what is this, guys? Here this is x of t plus t by 2. It is not overlapping with original, so there is no half wave even symmetry. Now amplitude reversal. So folding with respect to x-axis like this, and it is overlapping with original signal minus x of t plus t by 2, which is equal to x of t equal to x of t. So half wave odd symmetry is there here. Half wave odd symmetry, correct? So there is half wave odd symmetry, guys. So now we can see DC is there, cos term will come, no sin term, and in cos term only odd harmonics. So DC plus only odd harmonics of cos. Okay. So what will be the final answer? The x of t will contain c plus only odd harmonics of cosine terms. So this concept you can use in the option elimination. We will solve some question also, don't worry. Fine. Now let us take one more question. One more question. Okay. Now here you have to check. So tell me odd signal, even signal, nano, guys. So here it is a nano symmetry. Neither even nor odd symmetry, guys. Nano, correct? Now nano, guys. See, you can say it is an odd. No, guys, there is no odd symmetry. C is half wave, then folding with respect to y axis, it will be like this. Then folding with respect to x axis, it will be like this, guys. So there is no overlapping. So no even symmetry, no odd symmetry. It is nano signal, neither even nor odd. Nano, neither even nor odd, guys. Neither even or odd. Okay. So nano. Now tell me DC is 0 and non-zero, guys. So this is the fundamental time period, -1 and okay, this is 0. So here area of positive half cycle is exactly equal to area of negative half cycle but opposite sign. So total area under the over the fundamental time period is 0. Okay. So that's why DC also 0, guys, because area 0. DC is here 0. You need not require to check hidden symmetry. Is now nano. So AN also non-zero and BN also non-zero. So sin and cos both term will come, guys. It's a Fourier series representation. Sin and cos both term will come into picture. Now next you have to check only odd harmonics of sin and cos or only even harmonics, or all harmonics will come. So for that you have to check the half wave symmetry. So consider any half wave, guys. So this is a positive half cycle, this is a negative half cycle. I am considering this positive half cycle. Okay. So this is the half wave. Let's consider this half wave and shift this half wave by left side by the half fundamental time period. Half fundamental time period t equal to 2 seconds. Half fundamental time is 1 second. So subtract 1 from 0, so it will be at -1, it will be at 0. So left shift by half fundamental time period is like this. Is of t plus t by 2, x of t plus t by 2. Okay. And next is folding with respect to what? X axis, guys, amplitude reversal. Okay, folding with respect to amplitude reversal. So +3 become -3. It is increasing, it become decreasing. Be like this, the amplitude reversal, and it is overlapping with is x of minus x of t plus t by 2. It is overlapping with the original signal. So half wave odd symmetry is there. Correct? Half wave odd symmetry is present. What will be the final answer? So in its a Fourier series representation, find the trigonometric Fourier series representation. DC0, sin, cos both will come because nano signal, and only odd harmonics. So we can say only odd harmonics, only odd harmonics of sin and sin will come into picture. The Fourier series representation. So this is very much important concept, guys. If you have any doubt, then you can ask me, guys. If you have any doubt, then please ask. Done? Okay. Let me take one more question. Next question. So tell me here, even symmetry, odd symmetry or nano? Even symmetry, odd symmetry or nano, guys? Here we can say is an even symmetry. Even symmetry. Even symmetry, what is the confirmed part? No sin term. Gain will be 0, only cos term, and PC is 0 non-zero, guys. So here, what is the fundamental time period? From -3 plus 1. Okay, -3 to +1. This is the positive half cycle, this is the negative half cycle. Here +4, here -4. -3 plus 3. So the total area of positive half cycle is exactly equal to area of negative half cycle, but in opposite, in the sign. So total area for the fundamental time period is 0, so DC will be 0. So here DC 0 need not require to check any hidden symmetry. Here E is now no sin term, no DC, only cos. Now you have to check in cos all harmonics, odd harmonics or even harmonics will come. So half wave even symmetry, half wave symmetry concept you have to use. So select any half wave. I am considering this half wave, guys, and shift this half wave left side by the half fundamental time. Well, fundamental time period is 4. So shift this left side by the 2 seconds. This -1 will come at -3, 0 will come at -2, this 1 will come at -1. So like this. So this is x of t plus t by 2, x of t plus t by 2, and not overlapping with original signal. That's why there is no half wave even symmetry. Now next, plotting with respect to x-axis, amplitude reversal. So amplitude reversal. So this +4 become -4, +3 become -3. Will be like this. Is x of t plus by 2, which is equal to minus x of t plus reversal, which is equal to x of t. So here half wave odd symmetry is there. What will be the answer? No sin term, no DC, only cos, and in cos only odd harmonics. Only odd harmonics of cosine term will come. Correct? Fine. So guys, in this way we can solve the more question, guys, and option elimination method also you can use. Fine. Now in the next class, guys, next topic we will start. So we will find the Fourier series coefficient based on the knowledge of symmetry. Correct? Based on the knowledge of symmetry, we will find the trigonometric Fourier series coefficient as well as exponential Fourier series coefficient for some standard non-sinusoidal periodic, like this one and this question. And then we will start the next topic, that is the Fourier series properties of the Fourier series, the properties of Fourier series. So this content will start in the next class. So all of you, thank you so much watching me live on Wallah English channel, and please provide your valuable feedback after completion of this session, and the next part we will continue into subsequent module. Thank you guys, thank you so much.